Hi, we're here today to talk about cycle time reduction secrets, and this is part 6 in our webinar series. I'm Darren Harvell. This is Mike Boyd, who's been helping us out, taking us through this topic. We're here in our Experience Center room, one of the digital tools Makino uses to collaborate with customers to satisfy our commitment to help you in any way we can. And I want to make sure that if you have any questions, we get to those. So look in your top right corner, there's a Q&A. Go to the bottom, type in your question. Mike and I are going to take those at the end and make sure that we answer any questions you have. Mike, thanks again for joining us today. What are you going to share today?
So again, reducing your machining cycle time, focusing on the non-cut time. I'm going to show some features today that don't fall into the serial versus parallel process, but these are Makino design features that are standard on your Makino machines. And the one we're going to show today is called Inertia Active Control. And the Inertia Active Control is a feature that estimates the weight and inertia that you have on your pallet to optimize the acceleration and deceleration parameters. So the Makino machines, when they come in, they default to the heaviest rating setting for IAC. And that's for a safety reason. Because if you don't use it, then you're still safely operating the machine, assuming you got the heaviest pallet. But you're not realizing those savings. And the savings come in is when the feature's activated, you measure the weight inertia on the pallet, it resets parameters, ACK acceleration, deceleration parameters on your machine to optimize that rotation and take time out. And based on how many B-axis rotations you have in your cycle, you can realize a lot of savings here. And I'll show you one example. And this is a customer down in Kentucky. This is one of my turnkey projects that I executed. And this customer, before they had the IAC enabled, they were running a certain cycle time, and we went down and we implemented, measured the weight and inertia. Very easy to do. It's a simple cycle on the machine, and optimized that B-axis. And they realized a savings of 3.1% reduction in their cycle time. And what did that equate to? Well, it equated to 3,200 more parts per year. Now you're talking about increased revenue, reduced cost per piece. This is a prime example of that, using our Makino feature, Inertia Active Control.
What I love about this is it really makes the machine smart. You can go in and it's going to make a decision based on some information, and it's going to actually improve the output of the machine. We're going to get to see this. We've got an A51NX set up. We're going to get to see the difference in how this rotates, the speed. I can't wait to see this thing spin, so let's go see it.
Yeah, let's do it. So this demonstration, this is one of my favorites. This is Inertia Active Control. This is a very cool Makino feature. It's cool because what it does is it changes those parameters, those ACK parameters that we talked about. And I'm getting ready to show you. So the first demonstration is showing a heavy pallet. So in the machine right now on this pallet, I've got a heavier fixture. And you're going to see the difference between multiple B rotations between this pallet and an empty pallet. The empty pallet being the lightest IAC or Inertia Active Control setting. Now let's start, and I want to start on the control by showing you the screen that has this data recorded. I've already measured the weight and the inertia on each of these pallets, and it's very easy to do on a Makino control. But I've already measured it, and what I want to show you are those measurements and these settings. So we're going to pull up the work data screen, and on this screen you're going to see pallet number 2, and then pallet number 10 is out on the stocker area. And what I want to point out here is the different settings here for IAC. And this is pallet 2 is at the 3.5 to 6.9 kilogram meter squared. That's the heavier pallet. Pallet 10 is the empty pallet or a light pallet, and that's 0 to 3.5 kilogram meter squared. So because the machine now knows that it has these pallets, these fixtures on these pallets, it's going to automatically adjust the ACK parameters to give you a faster cycle time. So let's get to it. This first one, the heavier pallet, multiple B-axis motion, and we're going to record that time. It's still pretty quick. It looks really good. Multiple rotations, and we're going to we recorded that time. So let's bring the empty pallet in now so you can see the speed increase on an empty pallet. Initiate the pallet change. Coming into the empty pallet and the same exact B-axis rotations, and look how fast that is. And that B-axis rotation speed on our Makinos just amazes me every time. And the IAC takes it to the next level, so you can reduce your cycle time by optimizing your ACK and DEC parameters on your B-axis rotations. So we're going to look here at macro variable number 716 and 717. So 716, that's the heavier pallet, the same B-axis rotations as the empty pallet, and you can see you save between 716 heavy pallet and 717 light pallet. Now again, you take those rotations over the course of a full cycle, multiple B-axis rotations, running 24/7, and you're going to realize it's an immense savings just by turning on and implementing the Makino feature, and that is Inertia Active Control.
Thanks, Mike. It's always interesting to hear about improvements, but whenever you can come out to a machine and see it, it makes it all the more impactful. So thanks for doing that. We'd like to hear from you. If you want to go up in the top right corner and take a look at the Q&A, you can type in some of your questions there. We're going to be ready to answer those, so feel free to type those in now. Okay, hi everybody. Hope you enjoyed that. Thanks for sticking around for some questions with Mike. Mike Boyd, thank you for the demonstration, and thanks for being available for some Q&A now.
Yeah, thank you.
So Mike, to start things off, you had said in your demonstration that you had already measured the weight and inertia. You showed us how those had been changed. But the question here is, how do you measure the pallet inertia and the weight?
Well, before I dig into that question, I want to point out that something we didn't talk about, another axis that we actually employ this technology on, that's the Z-axis in our NX series machines. Also the A500Z, A800Z. Also look at the Z-axis to optimize that linear motion as well. In addition to that, our automatic tool change magazines also employ the same technology, where it actually measures the kind of the resistance on the motor to approximate the weight and optimize your ATC magazine as well. So this technology, I mentioned earlier, is that it's one of my favorites. It's easy to employ, and it's cool. So how do you measure it? There are built-in cycles that you run the machine through, that it actually moves. It rotates the B-axis left and right. We call it the dance. Dances. Dances a B-axis, dances a Z-axis, and it's looking at the load on the motor, the load on the servo to approximate that inertia and that weight on the pallet. So we didn't show it, but it does the dance, and it's real easy to do.
Okay, and then when you had that information, you also talked about the work data screen being where that information is shown, and you showed us that. The question here is, how do you get to that work data screen?
Well, under your the menu button up at the top on your control, you open up and you go to, there's a menu called work data. So you go to that and you can see all the information on your pallet. What you'll notice in our demonstration is that machine, the A51NX, was in front of our pallet shuttle system, the MMC2. And so you can see all of your pallets. So you can actually measure and have that data for all of your pallets within the system.
Okay, that's helpful to know as well. And a question here is asking about how, if there is a method, how do you automatically measure the inertia and weight? Is there a method for that?
Yeah, there's really three ways to do the dance. One of them is just manually. You can go in the function screen, and you can enable and you can start the actual measurement. Of course, you have to make sure you're clear of your workpiece. Everything's kind of back at home position, and manually you cycle start then, and it does the dance. The other way is automatically. We talked about that work data screen. You can actually assign to that pallet every time it comes in after a pallet change. It will measure that inertia. So that's one way you can do it automatically. There's a third way. You can uh, insert a macro call in your CNC program using G65 P9880, and that calls the cycle as well. So there's really two ways to automatically measure that inertia on your pallet and on your Z-axis.
Of course, right in the title of this webinar is saving cycle time, right? That's what this is all about. So implementing something like this, a concern about would that add cycle time? And I think this question is more around if you were going to check, if you had different jobs you were running and you were going to automatically check and set this up, would that add some cycle time to measure the inertia and the weight?
Well, the measurement obviously does add cycle time, but the thought there is that because you optimize, you're going to realize savings over the entirety of that cycle. So the measurement is, and I can't give you a number. It's different for each machine platform, but it will incur some cycle time during the measurement. I also want to point out, this is for horizontal machines, our NX series, MCC, our Mag 3, A500Z, A800Z, and the T1 all have this technology available standard.
And as you're mentioning some of those different models, of course, the A51NX that you were working with has a direct drive table. This question is around, does IAC work with different table designs? So if you didn't have that type of table, can you still implement IAC, or is it dependent on a specific type of table design?
When we first introduced this with our Pro 6 or Professional 6 control, it was only for the direct drive tables. However, now the newer versions also on your worm gear type rotaries, all the way, like I said, all of your NX series machines. So not just direct drive. This technology is available on all types of B-axis drives on our horizontals. Also, kind of want to point out that I mentioned the Z-axis too. It optimizes the Z-axis. Some of the other platforms, I think the MCC, the Mag 3, don't have that Z in and out with the table. Rather, the table moves in the X direction, left to right. So the X axis is also enabled for IAC on that. So you can optimize your X axis too on some of those platforms.
So the inertia and the weight, we're talking about understanding what those variables are so that we can speed up this table. Question here is around, can you explain a little bit about inertia and weight? What is the difference? When we talk about inertia active control, why don't we say weight, or what are they interchangeable, or can you explain a little bit more about those terms?
Well, I mean, your inertia, linear inertia, is basically it's the resistance to change in motion. And when you talk about linear inertia, really the unit is the same as mass. It's kilograms in this case. So that unit is the same. So you're just looking at the resistance to that change in motion. When we're talking about the rotary axis, you're talking about moments of inertia or angular inertia, and that takes into account the radius from the center of the rotation. So that's why you see the difference in units on the work data screen. In that linear axis, you see just kilograms, and then the rotaries, you see kilogram meter squared. So that's a function, but really the thing that you see that's different is the mass, the kilogram. So during that dance, we're measuring again, we're approximating what that inertia value is during the dance based on how hard the motor or the servo is working.
That's a good explanation. Yeah, when you think about the radius, right, where the parts and the pallets are sitting relative to the center of rotation, that makes sense the way you explained it. And when you went to that work data screen you were just referring to, you talked about some of the units there for inertia, and we saw that there were some different settings. Does Inertia Active Control, does it have incremental changes, or is it just a slow setting, fast setting? Is there infinite changes? Can you explain a little bit more about that?
Yeah, so based on the platform, what machine you're implementing this on, you have multiple levels of settings. You can have 3 to 7 based on the machine's platform. I believe the NX is you're right around 5 or 6 different settings. Um, you can get up to seven different settings on the A61 and XB version, the newer versions. Um, so yeah, there's multiple settings. It's not just slow or fast, which helps to really optimize that that setting and your act and deck parameters.
So there's different speeds that you could achieve. Yeah, so that's important to understand. So as you're thinking about a different application, what the weight may be, a person here is asking, if you know what the weight is, let's say you know what the pallet is, you know what the parts you're going to put on it. If you just know that weight, can you somehow just put that right into this control to allow it to make that decision? Or you described a little bit earlier those methods for automatically measuring. Is there a way to do that, or you still have to go through those steps you described?
Yeah, you still have to allow the machine to measure it because like I said, the other factor here is the radius on the moment of inertia, the CG, where that is from center of pallet. So it's going to cause that motor to work a little differently if that's different with the same mass, but a different radius from the center. It's going to cause that motor, that axis, to work differently harder than others. So we really want the machine to measure that. So there's no way to manually input any of these values. Now you can manually delete. You can go in and delete the value. In that case, if it's enabled, then it defaults to the heaviest pallet load.
And you would do that in the work data screen.
You do that in the work data screen, correct?
Makes sense. You also shared with us an example of a savings on a turnkey that you were involved with in the past. Question here is around turnkeys that Makino applications engineers are working on. How often does IAC come into play? Is it something that just always automatically gets used, or does it depend on the application?
Well, part of turnkey, 2 things we guarantee with a turnkey, and that's quality levels and cycle time. So we're always looking to optimize and squeeze seconds out of any cycle. So this is a great tool for us to implement, measure that inertia on the pallet and the z-axis, and optimize those cycles. So yeah, we do. We look at this obviously with all of our turnkey and integration projects.
Okay, and we've got just a couple more questions here for you, Mike, before we wrap up. And this question is asking about the possibility of a safety issue. You had mentioned during your demonstration that the machine comes in by default at the slower setting for safety.
Mm-hmm.
So what type of risk is there with implementing IAC? Is there a possibility you could damage your machine if you don't do something right? Can you give us more insight into that?
Yeah, if your settings are incorrect and you've got a heavy weight, but you've got a quick ack and deck setting, you could eventually you'll get into a overload condition on the motor or the servo, and then obviously if you continue that, like anything else, you could damage the machine. So you really want to measure that pallet before you get it in there and turn on and enable IAC. And while I'm talking about enabling IAC, there's other ways you can enable it, because you can change a parameter on the machine. So by default, IAC is always on and enabled. You can manually turn it on in the function screen, or you can use an M code in your program. There's an M code to turn it on and turn it off.
So that's important to know, that you mentioned there could be some other indicators, right? It's not like you're just automatically going to wreck your machine if you make a mistake. There's going to be an indication. You're going to probably get a servo overload. There's going to be some warning, some indication that something isn't right. So it sounds like there is a low risk for an immediate damage to a machine.
That's correct. Yep, I agree.
Okay, makes sense. That's what I would expect. And to wrap things up here, Mike, we're just going to share with everybody that if you go up into the top right, you can see handouts listed there. If you go into handouts, we have a few documents. There's a contact info sheet there, so you can use that. If you would like to set up a one-on-one with any of our subject matter experts, please reach out to us. We'd love to collaborate with you, listen to what some of your challenges are, and see how we might be able to help and partner with you to help you meet the needs and goals you have. So reach out to us. We'd love to talk to you more. And then also you're going to see there, we do have the few slides, Mike, that you used in your presentation. So they can go in there. You can download those. And then also you'll see the A51NX and the A61NX brochure. There's great information about those machine platforms in that brochure. And about midway through the brochure, there's some more information about IAC. So you can read that there, as well as a lot of the other options and features and advantages you get with that machine platform. So please download that. And I want to thank everybody again. Thank you, Mike, for taking the time for this demonstration. Thank all of you for joining us, and we'll see you next time.
Thank you.